let's move to the next question. We have three charges now. We have charge 1, we have charge 2, and we have charge 3. So the first question says state Coulomb's law in words. So that's where you are going to the exam guideline and take the definition as it is from the definition from the exam guideline. So from the exam guideline, Coulomb's law states that the magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That's how we state the Coulomb's law. So the second question says calculate the net force acting on charge 3 due to the presence of charge 1 and charge 2. So before we start calculating first, we should check the direction of the net electrostatic force or the resultant. So let's say first we start by drawing a free body diagram. So this is F3, it's charge number 3. So let's say this will be electrostatic force 3 on 1 to that direction. Since 1 is positive and 3 is positive, so they repel each other. And then this 3 will move to charge Q. So this is the electrostatic force 3 on 2. So this is the electrostatic force 3 on 1, and then this is electrostatics 3 on 2. And then the resultant should be this direction. So this should be the FR, the resultant force. So this is the angle. That means we should also calculate the direction of the electrostatic force. So let's say now we start. Okay, so first we say the electrostatic force 3 on 1 for now is equal to K, that's for constant, charge 1, charge 2 all over R squared. So what is K? K is 9.0 times 10 to the 9. Then charge 1. Now we're talking about charge 1 and charge 3. So in charge 1 we have 6 is microcoulomb. That means it's 6 times 10 to the negative 6. Now charge 3 is 5 times 10 to the negative 6 all over. So what is R? R is 30. That means 30 divided by 100 should be 30 divided by 100. It will give us 0.3 meters. So this is 0.3 meters squared. So from here, the answer is going to be 3 Newton. So it's 3 Newton where the direction to the left. So that's where the direction of charge 1 going to 3 or 3 to 1, something like that. So now let's say now electrostatic force 3 on 2, it will be K Q1 Q2 all over R squared. So what is K? We know K is 9.0 times 10, so it's 10 to the power 9. Charge 1 Now we're talking about Q2 and Q3. So Q2, we ignore the negative, we take it as 3 times 10 to the negative 6. The other one is 5 times 10 to the negative 6. Divide. Now, what is the distance? Is 10. That will be 0.1 squared. So, from here, we get 13.5 Newton. So, it's 13.5 Newton where it's going down this one. So, let's say it's downwards from the free body diagram. It means downwards. So from here, let's move to the next page. Now we see F net is equal to the electrostatic force 3 on 1 plus the electrostatic force 3 on 2. Now, but since the charges, they form a triangle, this is a right angle triangle, that means that's where we are going to talk about the theorem of Pythagoras. So we know the theorem of Pythagoras as r squared is equal to x squared plus y squared. So this is what we apply. So the F net is the same as r squared. The F 3 on 1 is the same as x. The F 3 on 2 is the same as y. So we apply the mathematics here. So now let's say the 3 on 1, the 3 on 1, we got 3 Newton. So this will be 3 squared plus the 3 on 2, we got 13. So it will be 13.5 all squared. So from there, that's where we're going to take the square root, F net square root. So we take the square root both sides. Then this side will be left with F net is equal to, from the calculator, here we get 13.83 Newton. So it's 13.83 Newton. Now, since we want the direction of the net force, that's where we're going to apply the trigonometric ratios. Can be tan, can be sine, or it can be cos. They are all allowed or accepted. So it can be tan theta, it can be cos theta, or it can be sine theta. So any one is accepted. So for now, let's say we choose a sine. So from our triangle, this is what we have. We have 3 over 13.5. So why 3? 3 is adjacent, 13.5 is, so the 3 is opposite, 13.5 is our adjacent. Remember, this is our hypotenuse, the F net is the hypotenuse. So from here, let's say we take theta, and then we're going to have arctan 3 over 13.5. So from the calculator, we got 2.53 degrees.